So today we are going to design Turing machine. I hope I am audible to you people.
Yes, sir.
Am I audible?
Yes, sir.
Yes,
Okay.
sir.
Yes. So okay. Uh, we are going to design a Turing machine to find one's complement of a given binary number. So binary number is a number which is represented by using two symbols, that is 0 and 1. So this is an input binary number, and complement or one's complement of a binary number is nothing but all the digits are interchange. That is 0 becomes 1 and 1 becomes 0. That is we apply a NOT gate to it, right? And the resultant is 1010. So if this was the input, the output would be the reverse of it, right? And now we need to design a Turing machine that would produce the reverse of a binary number or one's complement of a binary number. If we consider another example, like suppose there is an input 1100, and we want to complement this input, then again your 0 will become 1 and 1 will become 0, right? So this would be 0 0 1 1, right? So this would be the output that is required. Similarly, if some input is like this 1010, then after its complement the output should be 0101, right? So you should design a Turing machine in a way that whatsoever be the input, it would always produce complement of it, that is one's complement of that input, right? So what could be the logic? So the logic is very simple. You read the complete string, go to the last end, come back, and while going back to the start, just reverse whatever you read. If you read a 1, make it 0. If you read a 0, make it 1. Right? You can do the same thing by moving from this direction to the right words also. Right? So I will use the first logic. What we would do, we would design a Turing machine, right? So the Turing machine, for designing Turing machine, we need to consider the tape symbols. So 0 is the first tape symbol, then 1 would be the second tape symbol, and the last input that can be there on the tape is a blank, right? And then the Turing machine will start from initial state Q0. Right. In Q0, what the Turing machine is going to do, I said that it would read the complete string and move right to the extreme end of the string. So it would be in Q0, keep this 0 as it is and take a right move, right? If in Q0 it gets a 1, again it would be in Q1, it will stay in Q1, make this 1 as 1 and take again a right move, right? Then finally, what would happen at the end? After reading the complete string, the pointer or the control, finite control, would be pointing to a blank symbol. This would indicate the end of the string. So we would be changing the state from Q0 to Q1 so as to mark the end of the string. Keep this blank as it is, and now we'll move to the left. We'll take a left move, right? So this would be for Q0. Then the next state that is arised is Q1. Now in Q1, whatever be the input, we need to reverse it. If 0 is the input, we need to make it 1. If 1 is the input, we need to make it 0, right? So in Q1, if 0 is there, you would stay in Q1 itself, make the 0 as 1 and take a left move. You will go on doing this until you get a blank in Q1. If in Q1 you get a 1, you will make this Q1 as, this 1 as 0, and again you will move to the left, and this is going to continuously happen. 0 will be converted to 1 and 1 will be converted to 0 till the point you get a blank in Q1. As soon as you get a blank in Q1, this would be indication that you have reversed the given input. You have obtained the ones complement of it. So you need to move to the final state. You may keep this blank as it is, and you can go to a halt state, or you can go to left or right. Right. So this is how you would be converting a given. Uh, this would be QF, and there would be no transition after reaching out QF. Right. So this is QF. So this is the Turing machine that would be accepting binary input and would produce a complement or one's complement of the given input. So let us check if it is working in the same way or not. Like, let's consider the last input, that is 1010. So we will give this input in Q0. Before this there would be blank, after this there would be a blank, right? So in Q0 if I get a 1, so in Q0 if you get a 1 you would be just moving to the right. So you would just keep the 1, you will read 1, be in Q0, then read the remaining input, right? Then again you would read Q00, you will keep this 0 as it is, take a right move, be in Q0. In Q0 you would then read this 1, move to the right. In Q0 you would then read this 0, be in Q1, and finally after reading all the input you would be in this particular context, in this particular configuration. That is, you in Q0 you would be pointing to a blank, right? So after Q0 blank, we have a rule in Q0. If we get a blank, we have a rule Q1, B, and L. That is, you would go to the new state Q1, keep this blank as it is, and now take a left move. As soon as you will take a left move, this Q0 will move at this particular position, but the state is now changed to Q1. So the next configuration would be like this: blank 101. Then you would be in Q1 and pointing to the 0, and then the end blank would be as it is, right? So in Q1, now in Q1 the input is 0, and we said that in Q1 whatever be the input we would be reversing it until we get a blank. So in Q1 if the 0 is input, you would be making this 0 as 1 and take a left move. So the next configuration would be 10, then you would be in Q1, this 1 will be as it is and the 0 is converted to 1, so the last one will be as it is again. So the last 0 is now converted to blank, and then there would be a blank again. Now you are going to do the same thing until you get a blank in Q1. So at the end, you would be reading like this blank, then you would be in Q1 and reading a blank as input, and the remaining everything is converted to the reverse of it. So the input was 10, because here you are reading 1, so you will make it 0. After that, you will read this 0 and make it 1. After that, you would be reading this 1 and make it 0. So you would be having 0, 1, 0, 1, 0. The input would be like this blank blank, and then the input is 0101, and then a blank, right? So as soon as in Q1 you get a blank, this would go to a final state. So you would keep this blank as it is, then you would go to a final state, and this would be 0101, and the blank as it is. So this is the required output. Our input was 1010, and the final output that we got is 0101. That is nothing but one's complement of the given input. So the next state will be like this blank. You will go to QF, alt blank 0101 would be in the output, and this is a blank. So this is the required output. This was the input. You can see that this is a complement of the given input. I hope this is clear to you.
Yes, sir.
Right. So now, if you have copied, then we would be designing a Turing machine to find whose complement of a binary number. Shall we? Yes. So I'm starting to design Turing machine to accept find two's complement of a binary number. So can anyone tell me what is two's complement of a binary number? Two's complement of a binary number is nothing but first we obtain one's complement of the binary number and then add 1 to it. It becomes two's complement of a binary number, right? It's like this. So suppose the input is again given as 0101, and now we are required to find two's complement of this. So first what we'll do, we'll obtain the ones complement of the given number. So it would become 1010, and then we'll add 1 to this particular thing. So this would become 01 is 1, 1, this is 1 as it is, this is 0, and this is 1, right? So here you can see this is the two's complement of the given number. So if the input is 0101, the two's complement of 0101 is 1011. Similarly, if the input is 0100, let's obtain two's complement of 0100. So for that, you would again convert it to one's complement, so it would become 1011, and then you would be adding 1 to it, right? So this would become 1 and 1. 1 XOR 1 is 0 with the carry 1, right? So this would again be 0 with the carry 1. So 1 and 0 will be 1, and this 1 will be as it is, right? So you can see that this is the two's complement of 0100, right? That is 1100. The next is again another example we can consider from here itself, that is 1010. So if 1010 is the input, then let's obtain its ones complement first. So the ones complement of 1010 is 0101, and then we'll add 1 to it. So the output would be 0, then 1 carry. So 1. The last carry is ignored over here, right? So this is 0 1, and then 10 is 1, and this is a 0. So you get 0110. So this is 2's complement of the given binary number. Now we need to design a Turing machine that would be converting this input. Suppose this is the input, it would be producing this as the output. If this is the input, it should produce this as the output directly. So this was the internal operation, right? But this won't be shown by the Turing machine. We just want to give this as the input Turing machine, and we want that the Turing machine should produce this particular output, or should produce the two's complement of that particular given number. How could you design a Turing machine for this purpose? So can you identify a common thing from this by looking at the input and the output? Can you identify a logic? Just observe these two things. This is the input and this is the output. What is common in this? This is the input, this is the output. What is common? This is the input, this is the output. See, if the input is 1 over here, the output is 1. Input is 0, output is reverse. Input is input is 1, output is 0. Input is 0, output is 1. So from this point onwards, the rest is reverse, right? From here, if the 0 is input, 0 is the output. 0 is input, 0 is the output. 1 is the input, 1 is the output, right? But after this one, 0 is the input, reverse is the output, right? So from this point here, everything is reverse, right? Again, look at this input. 0 is the input, 0 is the output. 1 is the input, 1 is the output. After this one, if 0 is the input, 1 is the output, 1 is the input, 0 is the output. So after this point, everything is again reverse towards left. So can you tell me the logic? What is the logic over here? See, we are moving, like consider another example. Uh, Let us consider 1110, right? So when we obtain one's complement of this, you would get a number 0001, right? And when you add 1 to it, you would get 0, then this is 1, and then this is 0100, right? So if you look at this again, 0 was the input, 0 is the output. 1 was the input, 1 is the output. After this one, whatever is the input, that is reversed. If it was 1, so it becomes 0, 1, 1, it becomes 0. After this one, If it is 0, it becomes 1 in the output. If it is 1, it becomes 0 in the output. After this one, again, its input was 0, so it becomes 1. After this one, everything was reversed. The logic over here is very simple. You will read the input from right hand and move towards the left. The logic that we used here itself, right? So while moving back until you get the first one, everything will be as it is. But as soon as you read a first one, after that one, whatever be the input, everything will be reversed, right? So you would start reading from this end, move towards this end, right? If you get a 0 as input, keep this 0 as it is. If you get another 0, keep that 0 as it is. If you get first one while reading, keep that one as it is and change the state, right? And now in this state, as you move to the new state after reading first one, so in that new state everything is to be reversed. If in that new state you get a 0, make it 1. If you get a 1, make it 0, right? We will design a Turing machine for that purpose. Like, the input would be either 0 or 1, or on the tape you can have a blank symbol, right? So again you would start from initial state q0. In q0, the first state will be just to traverse to the right end of the input. So the same rules will be there. That is, in q0, if you get a 0, you will stay in q0, keep this 0 as it is, take a right move. If you get 1, you be in q0, make this 1 as it is and take a right move. And as soon as you read a blank, this would be indication that end of the string is obtained. So you need to remember the that we are in reverse direction now. So change the state to q1, keep this blank as it is and take a left move. Right now in q1, whatever be the input, you keep it as it is until you get a first one. So if in q1 you get a 0, you will be in q1, keep this 0 as it is and take a left move, right? But in q1, if you get the first one, so this first one would be an indication that after this one you need to reverse everything, right? So after reading this one, but you need to keep this one as it is. So after this, for remembering that after this you have to reverse, you need to change the state, right? So you'll change the state to q2, keep this one as it is and again move to the left, right? So now you would be going to state q2, right? And now in state q2, whatever be the input, you will just reverse that input. If the input is 0, you would stay in q2 itself. If the input is 0, you will make it 1 and take a left move. If the input is 1, you would stay in q2 only, but make this 1 as 0 and take a left move. You would, whatever be the input in q2, you would just reverse it. And finally, after reading complete input, you would get a blank in q2. So this blank would be indication that you have reversed everything after the first one, and then you would be reaching a final state. So you will go to final state qf and then keep this blank as it is and you can halt, right? So this qf would be a final state. There won't be any transition. So this is a Turing machine that would accept one's complement of a given binary number. So it would compute two's complement of a given binary number. I hope this is clear to you. So in this way, you can design a Turing machine that would uh, compute anything. You can even design Turing machine for computing multiplication of two numbers. So for that purpose, what you would be doing, you would be copying and pasting. Now here, the Turing machine would act as a copier of string. So for now, we someone design a Turing machine to increment a given binary number. Simple. Number can be anything, 0 1 0 1. You need to increment it. That means you need to add 1 to it. Tell me, someone tell me what would be the output. 1 0 0 1 can be the input. Increment it by adding 1. You'll get some output. You'll get some output over here also. Consider another example, 0, 0, 1, 0, incremented by 1. You'll get some other output, 0, 1, 0, 0, plus 1. You'll get some output over here. Try to find the logic in these output. Try to find the link between this output. That is the link between the input and the output. Like if you get this, if you do addition of this, you would get 0 1 0 1. If you add this, you would get 0 1 1 0. If you add this, you would get 1 1 0 0. If you add this, you would get 1 0 1 0. Try to find the logic. What is the logic over here? See, for logic, just read. If 1 was the input, output is 0. If input is 0, output is 1. If the input is 1, output is 1, input is 0, output is 0. Right? So here there is a change. After this, there is a change. From here, if you get 1 as input, it is reverse 0. If 0 is the input, it is 1. If 0 is the input, it is 1. And 1 is the input, it is 1. So from here, there is a change. That is, after 1 is there, 0 is there, 0 is there, 1 is there. After this 0, everything is same. Here also 0 is there, 1 is the output, 1 is the input, 1 is the output. Right? So here there is change from this point. And 0 1 0 0, 0 is the input, 1 is the output. 0 is the input, 0 is the output. 1 is the input, 1 is the output. Again, changes from here. So if you look at this on the input, up to first 0, everything is reversed. Up to first 0 from right hand, everything is reversed. The remaining things remain as it is. So make a logic. Logic is simple. Start from Q0. In Q0, if you get a 0 as input, or you will get a 1 as input, or you will get a blank as input. Yes, someone tell me what would be the logic. So first state Q0, you will just go to traverse. So you would be in Q0, keep this 0 as it is, take a right move. Be in Q0, make this 1 as it is, take a right move. On getting a blank, change the state because you are going in reverse direction. Keep this blank as it is and take a left move. Now the important part is Q1. This is very important state in all such design. So now in Q1, if you get a 0 as input, so this would be the first 0. So first 0 will be as it is, and after first 0 will be reversed, and the remaining thing will be as it is. So as soon as you get a first 0, you would change the state to Q2, make this 0 as 1 and take a left move, right? In Q2, you would be getting different input. So in Q2, as you know, we have reversed up to first 0, right? So if you are in Q2, that means you have read the first 0. So you would be in Q2, keep whatever is the input as it is. If it is 0, keep it as it is. Take a left move. If in Q2 you get 1 as the input, be in Q2, keep this 1 as it is and take a left move. And in Q2, if you get a blank, go to a final state, make this blank as it is and halt, right? And in Q1, if that was 0, then you have changed it to 1. But in Q1, if you get a 1, you will reverse it. So, but you would be in Q1 itself. So 1 is 0 and 0 is 1, and you would take a left move, right? Okay, so you would reverse everything until you get the first 0. On first 0, you will reverse it and change the state. As soon as you have changed the state, everything would be same, right? So this is Turing machine for incrementing a binary number. Simple. So I will give you a task. You need to design a Turing machine to you all need to design a Turing machine that would act as a eraser of string. Okay.